Hi, so we're going to take a look at this titration practice problem. Go ahead and pause, read the problem, and try to get it started on your own. Okay, hopefully you tried to work it out on your own. If you're back, you maybe want to see what the correct answer is, or you want to check your work. Now, one big mistake that students make often is trying to use M1V1 equals M2V2 or C1V1 equals C2V2 for titration problems. So these are not going to give you accurate answers here. While they may work in some reactions, they're not going to work in all reactions. These are dilution formulas. So we only want to use them for dilutions. And how can I tell when I'm using a dilution or not? A dilution is one substance is your one, like M1V1 is of one substance, and then the other substance, the twos, are the same substance. So chemical reactions require mole ratios to go between two different substances. So if we're looking here, we have sulfuric acid that we're trying to find, but I'm giving you information also about sodium hydroxide. These are two different substances. And so I will need to look at a mole ratio, and the dilution formula doesn't have a mole ratio in it. You know, there are some versions of that formula that does have the mole ratio there. I highly recommend that instead of relying on a formula where you plug numbers in and you chug answers out, that you really understand what you're doing by trying to use dimensional analysis and your relationships that you understand about molarity and mole ratios to solve the problem. So if you want to pause here and keep going, then try it again. If you're still a little stuck, the first thing we need if we need a mole ratio is a chemical reaction. So let's take a look at the chemical reaction. And pause if you want to try to write the reaction first. So the first thing that I like to do when I'm writing chemical reactions, anytime I have ionic or acidic compounds, is to write a box of work. And what I like to put in this box are ions. So for sulfuric acid, every acid has H+. And so the other thing that comes after the H+ is in front of the name of the word acid. So sulfuric is in front of acid. We look for sulfuric to figure out what our anion is or what our negative ion is. Sulfuric comes from sulfate. 8 goes to ic in acid naming. So we need the sulfate ion, capital S, capital O, 2 minus charge with 4 oxygens here. To write the formula for sulfuric acid, it's going to be 2 H's for every 1 SO4 for every 1 sulfate. And the state of matter for acids here are going to be in aqueous. And we're reacting that with sodium hydroxide. Sodium has a charge of +1, and hydroxide's a polyatomic with a charge of -1. So when we put those together, we get one of each, 1 sodium, 1 hydroxide, because their charges balance out. This will also be aqueous. We can tell they're going to be aqueous because we're looking for concentration and molarity. And typically things are going to be dissolved in water when we're doing these kind of reactions. Now we want to figure out what our products are. We can just go and switch our ions. So the H is going to hook up with the OH, and we're going to make H+ and OH are going to be together. And the sodium is going to grab the sulfate. So we're going to see the sodium hook up with the sulfate. Just reorder them on the right side and you can write new formulas. Now, when we put HOH together, that's 2 H's and an O, that is water. And that's going to be a liquid. Water's not going to be aqueous because it is aqueous water would be pure water. So it's just a liquid and it's pure. For the sodium sulfate, we need 2 sodiums to balance out every 1 sulfate. And that's based on the charge. Let me know if you have any questions about where I'm getting any of this stuff from for your nomenclature. To balance the equation, we need 2 sodiums on the left side, and we need 4 H's and 2 O's on the right side. So that will help us balance. So now I have a mole ratio here, and that's what I need. I have a mole ratio for My sodium hydroxide is 2. My sulfuric acid would be 1 because there's nothing in front of it here. So let's look at how we will solve the problem now with a mole ratio. If you want to stop here and give it another shot, go for it. So my suggestion to you is to figure out where we're going to start. Writing, what am I going to start with? What's my unknown? And what are some conversions that I can use? Sometimes I can write equations here to help me out. So what am I trying to find? I'm trying to find the concentration. So I actually have two unknowns. I have moles, specifically of sulfuric acid. Oh, sorry. I have molarity. I'm trying to find the molarity of sulfuric acid. So let me write it this way. Molarity is actually 2 units in 1, so derived unit. So really, we're looking for the moles of sulfuric acid, and we're looking for the liters of sulfuric acid solution. Because molarity is moles of solute over liters of solution. So we need to figure out what information we have to start with. Now I have a bunch of information. Let's just look at one piece at a time. So let's use some color coding here. So to find the liters of sulfuric acid solution, do I have anything given to me in the problem that's going to help me with that? Yeah, we have 15 milliliters of the sulfuric acid. So reading in between words like of the are going to help you figure out it's not 25.10 milliliters of sulfuric acid. It's 15 milliliters of sulfuric acid. So that's one place where I can start. The 15 milliliters of sulfuric acid, that's going to help me find the liters of sulfuric acid because I need those two things together, the liters of sulfuric acid and the moles, to find this. So that's where I'm going to start for one piece. For the other piece, we're going to have to rely on the sodium hydroxide to tell us how many moles of sulfuric acid there were. And this is where the titration comes in. So this information is going to help me with that. Now, the molarity is not a good place to start because it is double unit. It's 2 units. How do you know how to put it into a dimensional analysis? Do you put the moles on top? Do you put the liters on top? If you're not sure, then the better place to start is going to be the 25.10 milliliters of the sodium hydroxide. Let's start there. So that's going to be where I start to solve my moles of sulfuric acid, which means that the molarity of the sodium hydroxide is actually a conversion factor. Now that I have all this written down, I can kind of remove the question here for a second and we can look at what we have down here. So molarity is really moles per liter, right? So I can turn this into an equality. When I teach this, I like to have my students write out their conversion factors as equalities because it helps you remember that you can put one on top of the other. And the whole point of dimensional analysis is that we're multiplying something by essentially 1 and not changing the original value of the thing. We're just representing it differently. I'm going to abbreviate solution here as SOL apostrophe N. So I can use that as a conversion factor, which means I can write it as 0.340 mole of sodium hydroxide on the top and 1 liter of sodium hydroxide on the bottom. Or I can write 1 liter of sodium hydroxide on the top, and I can say 0.340 mole of sodium hydroxide on the bottom. And I can use either way. And instead of writing it in one of those ways, I can write it as an equality, and that kind of helps me see that I can do either one of those. So that's a conversion factor. And so what I like to teach my first semester students when we're learning dimensional analysis for the first time is if you can touch your unit for the start And then you can go all the way through your conversion factors to get to your unknown. You have all the conversions you need. So, or if you can back up from your unknown and go all the way to your start, you have the conversions you need. So here, if we start with mole of H2SO4, we don't have that. Milliliters of NaOH. Well, I have liters of NaOH. So let me just write a conversion from milliliters to liters. Whatever conversion you want, just write that conversion. I'm doing a lot more than you might do just to help show you where I'm getting all of this from. So milliliters of NaOH take me to liters of NaOH. Liters of NaOH take me to moles of NaOH. Now I need to connect moles of NaOH to moles of H2SO4, sulfuric acid, and that's where my mole ratio is going to come into play. So for every 1 mole of sulfuric acid in my reaction, I have 2 moles of sodium hydroxide. Now, if you're doing your lab, if you're doing a lab for this and you have hydrochloric acid and sodium hydroxide, it would just be 1-to-1 here. It's important to still write it out though, because you're showing me that you understand the mole ratio is needed to solve a titration problem. So now this is all the stuff that I need to go from milliliters of sodium hydroxide to moles of sulfuric acid. Let's just take a look and let's highlight, I can highlight these for you. So these are the conversions I'm gonna need to take care of all the stuff in blue. And the mole ratio I get from the balanced chemical reaction. So 1-to-2, 1-to-2. For the yellow part, I just need a milliliter to liter conversion for that one. But instead of NaOH this time, we have H2SO4. And so that's going to help us go here. So I've tried to color code it for you to see what conversions you're going to use. So if you want to pause and try to set this up, go ahead and do that. Okay, let's do part 1. Let's find the moles first. So to find the moles, we're going to start with 25.10 milliliters of sodium hydroxide. In order to help my dimensional analysis go in one chain, I sometimes will stack up the unit and the substance so that it, instead of stopping and solving at each section, which can actually introduce error into your work and take you a lot longer, like on your exam, just try to do it all in one long dimensional analysis if you can. This one, we won't do all of it in a dimensional analysis. We will do the two sections. So everything in blue, let's do all at once. So there are 1,000 milliliters in 1 liter. That's going to cancel out my milliliters of NaOH. Now I have liters of NaOH. And if you're used to stopping here and then solving, just pretend like we stopped. Okay, we have liters of NaOH on the top left now. How do we need to cancel that out? Put liters of NaOH on the bottom. Find a conversion factor that uses that. The conversion factor that I haven't used yet that has liters of NaOH is my molarity. Now be careful when you're putting your molarity in. Don't put big M up here because that means mole per liter. So what I've written here is mole per liter, and that's not what I want. I want MOL. So don't abbreviate moles as M. Write out MOL. So liters of NaOH cancel. Now I have moles of NaOH. And I'm trying to find the molarity of sulfuric acid, which means I need to have the moles of the sulfuric acid. So I can use my mole ratio last. For every 2 moles of sodium hydroxide, I have 1 mole of sulfuric acid. So I want to see this. If I was a lab teacher grading a lab, I would want to see your mole ratio written out as a conversion factor. So I'll just do a quick calculation. I believe that I calculated that wrong. That's what I get for using my phone times 0.34 divided by 2. So I get 0.004267 mole of H2SO4. And I can underline my sig figs. I'm not quite done with the problem yet. This looks like it's going to be 3 sig figs due to my molarity. I'll just underline those numbers to help remind me of my sig figs as I move forward. Now the next step was to find my liters of H2SO4. If I start with 15 milliliters of H2SO4, I need to find liters. That's going to be a simple conversion. And you may have your milliliter memorized differently. Maybe you have 10 to the 10 to the negative 3 memorized. That's fine. Just be familiar with this one as well, because it is still correct. Now that I have the moles and the liters of H2SO4, again, I can underline my sig figs. I can then find my molarity. My molarity is going to be my moles over my liters. So the molarity of the sulfuric acid that we're looking for is going to be 0.284 if we're rounding to 3 sig figs molar sulfuric acid. And that's going to be the answer. I hope this was helpful. If you need anything else, please shoot me an email or send me a text message.